I'm Michael Smolin from Samsung, and their SSD product marketing manager. I'm going to be talking a little bit today about latency and SSDs and how SSDs allow SolidFire systems to achieve better latency response for virtual machines. If we could step back a few decades, our old friend, the hard disk drive, has really been the basis of storage for many, many years. And the hard disk drive is a mechanical device. It's never been all that fast. It has a latency associated with rotating the physical disk underneath a magnetic sense head. And it also has a seek latency associated with track-to-track movement of the data that's stored on the drive. Now, while this drive has never been that fast because of its moving parts, there's been a big trend toward virtualizing data center workloads to make servers more efficient. And as we've taken the utilization of our systems to a higher and higher percentage, this increased CPU workload has placed an increased demand on the storage system to keep up and keep the processor supplied with the I/O it needs. And to make matters worse, a virtualized environment is running multiple different workloads, possibly different operating systems, and it has exacerbated the seek latency issue in hard disk drives and made each seek for each virtual machine, potentially we're sending this hard drive sense head all over the place to find its data. And so as the virtualization trend has progressed, solid-state drive penetration into the data center has increased significantly. And recently, the solid-state drive industry has been facing another challenge with trying to keep up with all this demand. As you all probably know, solid-state drives get bigger and cheaper and faster every year. And the way we've been achieving this is we've been taking a memory cell and we've been shrinking it down into smaller and smaller lithographies in silicon fabrication. And so as we've done this, we're now placing smaller and smaller memory cells next to each other in a two-dimensional plane. So each memory cell, because it's smaller, has less charge trapped on it, which is what stores the data. And as we shrink it down and cram more of them closer together, they're more able to interfere with each other. And this causes a reduction in performance. So in order to address this problem, the industry needed to come up with a new technology, and Samsung was the first to come up with a 3D NAND memory technology. So instead of cramming these memory cells together like people moving into denser and denser neighborhoods and smaller houses every year, I think of this as the high rise of memory cells. We developed a 3D technology we call VNAND. And VNAND allows us to go back to a time when we had nice big fat memory cells with lots of charge trapped on them, lots of ability to retain their information and deliver performance to servers and in turn to VMs. Samsung has now shipped 2 generations of this technology in production. And I think sometime in next year, the rest of the NAND industry, the rest of the solid-state drive industry will also begin to apply 3D technology to their solid-state drives and to servers. That is the majority of my pitch. How many of you guys are using solid-state drives in a virtualized environment today? Anyone evaluating solid-state drives for future deployment? How many of you guys use hard disk drives and never want to adopt a solid-state drive? Okay. Audience questions? Okay. Thank you for coming by.